You are standing on a world that should not exist, at least not according to everything astronomers believed a decade ago. The ground under your boots feels almost ordinary. The horizon curves the way it does at home, but the light overhead is wrong. It is dim, reddish, closer to an eternal dusk than a proper afternoon. Nearly 500 light years from here, a telescope named after 17th century mathematician spent years staring at one tiny patch of sky, waiting for a flicker so small it almost went unnoticed. That flicker turned out to be a planet, and in 2014, NASA announced something that had never been confirmed before: an Earth-sized world sitting inside another star's habitable zone. Reporters called it Earth's cousin. Scientists called it historic, a genuine turning point in the decades-long search for another living world. But the closer researchers looked at Kepler 186f, the more a second story emerged underneath the celebration, one involving a starving atmosphere, a frozen edge, and a question nobody has fully answered since. Here is how this discovery actually happened, and it took far longer than most headlines let on. NASA's Kepler Space Telescope launched in 2009 with one job: stare at roughly 150,000 stars and catch the almost imperceptible dimming that happens when a planet crosses in front of its star. Most of those dips are noise. Some are false alarms caused by binary stars or instrument drift. It took 3 full years of collected data before researchers isolated a signal reliable enough to confirm a real planet orbiting the outermost position of a 5-planet system around a small, dim red dwarf called Kepler 186. Announcing it required a published paper in the journal Science, peer review, and confirmation from multiple independent teams before anyone was willing to call it official. What set this particular find apart was not the discovery itself, since Kepler had already found thousands of candidate worlds by then. It was the size. Every previous planet found inside a habitable zone had been at least 40% larger than Earth, closer to a mini Neptune than a rocky terrestrial world, and scientists could not confirm much about their makeup. Kepler 186f broke that pattern. At roughly 11% larger than Earth, it fell squarely into rocky planet territory, the kind of world where solid ground, not crushing gas, was finally plausible. Elisa Quintana, who led the research team, explained the reasoning behind the search in a way that stuck with people. We know of exactly one planet where life exists, so we look for planets that resemble it. That single idea drove years of patient, unglamorous data analysis toward one confirmed signal. Jeff Marcy, an astronomer unconnected to the discovery, called it a historic step. Paul Hertz at NASA framed it as a milestone on the road toward finding a genuine twin of Earth. For a few weeks, the excitement was uncomplicated, spreading through newsrooms and classrooms alike. Then researchers started asking the harder questions, the ones size alone could never answer, and the story quickly grew more complicated than any headline had room for. Distance from star tells you almost nothing by itself, and Kepler 186f proves exactly why. The planet completes one orbit every 130 days, sitting just 32.5 million miles from its star. Drop that same distance into our solar system, and the planet would be circling comfortably inside Mercury's orbit, close enough to be scorched beyond recognition around our sun. Kepler 186 is not our sun, though. It is a cool, dim red dwarf, roughly half the mass of the star we orbit, radiating a fraction of the energy across a much smaller stretch of the visible spectrum. Because of that, Kepler 186f receives only about 1/3 of the sunlight Earth gets, which pushes it toward the outer, colder rim of its habitable zone, rather than a comfortable middle ground. Astronomers sometimes describe this position as balancing on the last livable inch before a habitable zone simply runs out. Picture what daily life would look like under that kind of star. Noon on this planet would resemble the muted light Earth sees, roughly an hour before sunset, permanent and unchanging, day after day, without variation. The star itself would loom about a third larger across the sky than our sun appears from here, yet somehow deliver less warmth, a strange contradiction between visual size and actual heat. There would be no crisp midday brightness, no sharp shadows cutting across the ground, just a long, dim reddish glow, stretched evenly across every hour of daylight, more like standing inside a permanent photograph than living through an actual day. That positioning cuts two ways, and this is where the story stops being simple. Sitting near the outer edge likely spared Kepler 186f from the worst of its star's youth, since young red dwarfs are notorious for violent flare activity capable of stripping a young planet's atmosphere entirely. Survival at that age would be a genuine advantage. But the same distance leaves almost no margin for error now. Push the temperature down even slightly through a thinner atmosphere or a shift in greenhouse gases, and this borderline world tips from marginally livable to a permanent deep freeze with nothing in between. This is where the optimism runs into a wall, and it is the part most coverage skipped past in 2014. Scientists still do not know Kepler 186f's mass, its density, or what material actually makes up its surface. One estimate places its mass around 44% higher than Earth's, but that figure comes from modeling, not direct measurement, and it remains genuinely uncertain until a future mission can confirm it through other methods. Without solid numbers on mass and composition, nobody can say with confidence whether this is a rocky, walkable world or something far stranger, perhaps a dense, waterlogged planet unlike anything in our own solar system. Even the word rocky, used so often in early coverage, was closer to an educated guess based on statistical patterns from similarly sized worlds than a confirmed fact. The star adds another layer of doubt. Red dwarfs are famous among astronomers for aggressive, unpredictable flaring, particularly during the first billion years of their lives, and that radiation can chip away at a planet's atmosphere over long stretches of time, even from tens of millions of miles away. If Kepler 186f absorbed heavy flare damage earlier in its history, whatever atmosphere it may have once had could already be gone, along with any chance of liquid water surviving on its surface. The version of this planet astronomers see today might already be the aftermath of a much harsher story that played out long before Kepler ever picked up its signal. Then there is tidal locking, a real possibility for any planet orbiting this close to a small, cool star. A tidally locked world stops rotating freely and shows the same face to its star permanently, baking one hemisphere under constant light, while the other stays locked in endless night, with no sunrise or sunset ever breaking the pattern. If that describes Kepler 186f, habitability would not spread evenly across the surface. It would shrink down to a narrow strip along the border between light and dark, a thin twilight band squeezed between two extremes, assuming anything survives there at all. Some researchers have modeled similar tidally locked worlds and found that fierce winds could constantly circulate air between the scorched and frozen hemispheres, potentially keeping temperatures survivable in that narrow strip, though this remains theoretical rather than confirmed for this particular planet. More than a decade later, scientists are still circling back to this planet, and distance is the reason why. At nearly 500 light-years away, Kepler 186f sits well beyond what even the James Webb Space Telescope can meaningfully analyze. Reading an exoplanet's atmosphere requires catching faint traces of starlight, filtered through it as the planet transits, and at this range, that signal is simply too weak to resolve with current instruments, no matter how sensitive they are. So the essential questions, atmosphere or none, water or ice, calm history or violent one, remain open more than 10 years after the announcement that made this planet famous. NASA itself pointed toward this gap early on, noting that missions like TESS and Webb would need to focus on nearer, brighter targets before a planet like this one could ever be examined in real detail. Sit with that for a second, because it leads somewhere uncomfortable. If a planet this celebrated, this close in size to Earth, still hides this much uncertainty, how many other so-called Earth twins, scattered through astronomy headlines, carry the exact same hidden gaps? Some may already be frozen, stripped bare, or locked into permanent extremes, and current technology simply cannot tell the difference between a living world and a beautiful illusion. That gap between what we can measure and what we actually need to know is the real frontier here, more important than any single planet's fate. It is also the reason serious astronomers tend to react to new Earth twin headlines with careful curiosity rather than instant celebration, because they have watched promising candidates like this one get more complicated the closer anyone looks. Kepler 186f will likely remain a symbol either way, proof that Earth-sized rocky worlds exist beyond our solar system, and a reminder that resemblance is not the same as habitability. Some researchers push for cautious skepticism toward every new candidate. Others argue that even a flawed, uncertain world like this one deserves continued attention, since ruling planets outteaches almost as much as confirming them. Which side of that argument you land on says something about how you weigh hope against evidence, and is worth deciding for yourself rather than borrowing someone else's certainty. Maybe the real lesson from Kepler 186f was never about finding a flawless copy of Earth, waiting somewhere in the dark. Maybe it was discovering how convincingly a distant world can wear the appearance of home while hiding something far less forgiving underneath the surface. This planet is still out there tonight, unreachable, still keeping its atmosphere and its history to itself, indifferent to every theory we have built around it. If future missions eventually confirm it is barren or frozen solid, would that change how you feel about the broader search for another Earth? Or would it only sharpen your interest in whatever gets found next? Tell me honestly where you land, because a debate like this deserves more than a quick reaction in the comments. Until better instruments close that 490 light-year gap, Kepler 186f stays exactly what makes this search worth following. A question the universe has not finished answering, and maybe never fully will.